Hello, this is Alfredo Alvarez. I'm making my recording for milestone 1 of my graduate research, season 2. We are basically working on using a stenographic projection to project on a sphere and be able to 3D print the sphere. For this milestone, the idea was to one, define the problem well, because at the beginning of the semester we didn't know how much of a research project this was, but we wanted to define and figure out what we wanted to do. And the second thing was try to get it to the part that we're actually projecting into the sphere and removing the parts that we don't need to project the shadow. I'm basically gonna walk you through. Right now I basically finished the UI, and I think I know how I want it to look. There's a lot of interactions that are still not placed, but we're gonna take a look at what's done and what's not. So the first thing that happened was during the first weeks of research was that I went and figured out if we could use a stenographic projection for this. One of the things that I found out is that because the way a stenographic projection works is that this pretty much locks us into spheres. So whenever we're going to do this, we need to use a sphere and a plane, and we need to use them at specific angles and specific things. I kept looking around, and I started working on a generalized version of this algorithm. So before I started programming, probably the first 2 weeks, I was just reading materials. I read a book on projections that I found. It's a really old one about how to make maps. And I got the idea that I could do a generalized case by pretty much creating a ray tracer and using it in Berkeley. But we're not doing that here. We're just trying to do a stenographic projection. Anyways, let's go around to the project really quickly. So I'm just going to kick it off so we can see it and then talk about things. So right now, our project's named Luminaire. This is a started screening. I'm basically using the framework that I did in the research semester 1. So we start and we get here. What you see here, basically, it lets us switch. The idea is that we can see what we're projecting here. And this is the voxel projection of it. So when I looked at the stenographic projection and how it normally works on OpenGL, you basically use a unity sphere, and you use a tessellated sphere on triangles to pretty much make it. So for us, that did not work for 2 reasons. One is that cannot be 3D printed because it doesn't have very good depth, and you can't really 3D print triangles of really high resolution. So what I ended up doing for the project is that I started using a tessellated sphere. Because of that, what I first did was take the bitmap that we had and map it into into a voxel plane, and that's what we're seeing here. This is a voxel plane. Over here, what we have is just a little gadget that I put in, so I could know where Z was, X was, and Y was, because at the beginning it was really confusing. So the blue dot is pretty much the point. It's a point of origin of the light that we will be using. What we have here that it shows, it's basically the projection. Right now from this angle you can't really see it very well, and I haven't really re-added the camera. But basically this is the projection, and these are the items that we need to take out. I still need, before I end the project, I need to make it switch. Right now if I go down, take it out, and just send another one, we'll get a different projection. And I can do it, and we can look at it. But basically, at the point we are, we have the light, we have the problem set up. We have the results. The big problem is that I need to take this, and I need to basically make the difference between this projection of the things that shouldn't be there from the actual sphere. So the sphere has 60 by 60 by 60 voxels that I basically decide what not to put and to put in the sphere. I have the code there. I'm gonna stop this and make it load so we can see the sphere in a second. But the point is that that's the next part of the problem I need to do. I was trying to get that done for today. I had a problem that basically my video card catch fire because I didn't clean my computer. I can send pictures, they're pretty funny. And that kind of got me a little bit behind, but I also don't know how to do it. So it was something that I need to talk with you, Professor. But the next step is to take the whole sphere, that it's a lot of voxels, and remove this, basically remove the projection. And as we move forward, something that I already figured out is how we're going to move this to 3D printer. So we're going to take this basically 3-dimensional array, and we're going to go and turn it into OpenSCAD. And once it's in OpenSCAD, OpenSCAD will let us turn it into STLs, which are the files that we can send to a slicer to print it on the 3D printer in G-code. I've made a demo that actually works and lets me 3D print stuff. That lets me send basically any type of voxels. And that's the reason why we're using voxels, is because they are like the basic unit that you can 3D print. Okay. So I'm just going to show the sphere, and basically this sphere that we have here, I need to add back the camera. I removed the camera when I did the last project last semester because I was working only on 2D. And I removed the camera from most scenes, and there was no easy way to add it back. To make this project look good, I need to re-add it. It's something that it's on the list of things to do. So let's talk a little bit about what's missing. So basically, we're missing the camera, and we're additionally missing we need to add a button so we can change into test mode. What test mode will let us do is actually look at the surface, just extend the surface like a lot bigger, and look through an actual made sphere and see how the light looks. Because right now we're doing this based on what we have projected, which is the square, this pattern, this hatch pattern. But we need to go back and make sure that it actually works if we want to complete. And that's not been done. Part of the problem is I've been having problems with the lights. I created a light manager, but it still needs a little bit of work because right now I don't know how to change the intensity of the light. And if I give it too much distance, I just for some reason, it just starts dissipating. So I need to figure that exactly. I haven't really worked with lighting that much in OpenGL, but that's something that I need to do before the end. Anyways, so problem solved. We got the projection done. It's not perfect. I think we need to work out on the size of those voxels. I think they're kind of too small. We got a voxel sphere done, and we figure out how to move all this to OpenSCAD for 3D printing. Things left, camera work, and adding this to the other, subtracting this from the other sphere so we actually have it, and making the demo mode. Okay, I'm going to stop, go to the folders really quickly. So I put everything inside a folder called Luminaire. Mostly everything was, so this project was interesting because it's been more a lot of like rewriting the same things over and over, more than actually doing a lot of objects. The last time, like Paleta UI, for example, had something like 30 objects. Here we have the cube plane, the cube sphere, the inverse stenographic calculator, the switch image command, which is something that we use to switch image, and the voxel base object, which is what represents a voxel, which is a combination of basically a cube and a position in a 3D space. So basically the cube plane and the cube sphere take a cube plane to be able to render itself, and he goes and renders at the beginning. This command encodes the one that renders the actual sphere. But this has been more like a lot of prototyping and a lot less like, let's give this structure and let's get it to like done. So here's the code that we use to turn the cube plane that we take in and basically turn it into the projection. So we just turn it into inverse stenographic calculator, and we go and work it out, and it comes out and gives us back, and then we just place those on space. Okay. So one thing that I want to do before the project ends is have Keenan, my professor, go and look at all my math formulas, make sure that my projections are projecting where they're placed in space. So let me stop this and show you the sphere. So when I enable the voxel sphere code, this is it enabling there. What I need to do right now is take those little pieces that we're seeing in the other video and subtract it from this, and that should give us the space below. With that said, I think it has a size problem. I think right now the resolution that I'm using is way too high. I think I probably should try to like reduce it to a unity sphere and just work based of magnitudes instead of based on actual basically what I'm trying to say is like I should normalize this instead of being using the magnitude for the sizes. Right now it's kind of like hard to really look at, but it's basically, I think it's like 14,000 cubes or something. Trying to see if I could find it here, the number. Comes out on output. Okay. Anyways, so that's basically the voxel sphere, and that's kind of where I'm at with the project right now. I don't have much else to say right now. It's been really interesting. I learned a lot, especially from how to read bitmaps, turning them into voxels, what voxels are, which is what Minecraft was made from, and how we can use this to actually make like CAD objects. I've been actually also looking at simplification methods, because right now this has a ridiculous amount of cubes, and there's no reason why when you have two cubes together that are like on the same plane, there's no reason why they can't be one cube. So I've been looking at ways to like reduce the voxel count. Like I say, my next steps is to talk to Keenan and figure out if my math equations are right, and then move in and like try to like start making this look better, because honestly right now this is super prototyping.